The second section of the IA is the exploration, and that's worth 6 marks. You need to do the following. The topic of the investigation must be identified, and a relevant and fully focused research question has to clearly be described. Now, I'll go into the particulars of that in a moment. The background information provided for the investigation must be appropriate, relevant, and enhance the understanding of the context. The methodology of the investigation must be appropriate to address the research question because it takes into consideration all or nearly all of the significant factors that may influence the relevance, reliability, and sufficiency of the collected data. The report shows evidence of full awareness of the significant safety, ethical, environmental issues that are relevant to the methodology of the investigation. That's a lot to get through. The template breaks it down slightly. Your research information and your research question go hand in hand. Your research question could be quite nicely in an introduction be the end of your research information. The exploration template includes research information, research question, hypothesis, hypothesis justification, method, independent variable, controller variable, safety consideration. Let me talk you through these. The research information is where you introduce the science behind your topic, and you start from the big topic, you start from the general physics to the more specific. I'll give you an example. You might be doing a sports one that relates to projectiles. Very common. So you talk about motion first. You would define SUVAT. You would talk about the fact that motion is dictated to by the behavior of objects in motion follows rules, right? And then you'd introduce the equations of motion. And then you would specifically introduce the situation that you want to do, which could be the launching of a hockey puck or etc. If you were doing, for example, music, guitar strings, you would talk about what sound is. What is sound? Sound is a vibration. And then from there, move into specifically the vibration of a string and how it's dictated by the tension, right? So you go from the big topic to the specific situation. To continue with my previous examples, if you were looking at oil, expansion and cooking, you would talk about expansion of solids and liquids, right? And then you would specifically talk about oil as a liquid and its behavior, right? And then end, and what's a nice thing to do, but isn't the only way to do this, a nice thing to do is to end with your research question. And the research question always follows the same structure. How does the independent variable affect the dependent variable? So how does the angle of the hockey puck affect the range of the puck? How does the temperature of the oil affect the amount of expansion? How does the temperature of the string affect the frequency, right? So always follow that structure. And then your hypothesis, you need to start introducing the high-level physics, which will eventually lead you to an equation or a hypothesized relationship. Now, there are 2 types of IA. The ones where you're dealing with the unknown, right? And the ones where you actually have some kind of prediction. Let me deal with the ones where you have some kind of prediction first. For those, you will need a hypothesis and a hypothesis justification. Your hypothesis will be an equation, right? But your hypothesis justification is how do you apply the research information? How do you go from the research information to that equation? Okay, so in the case of strings and temperature, guitar strings and temperature, there is actually a relationship between frequency and density of string. Right, so how does that relate to temperature? Well, then you then have to look for a relationship between density of string and temperature, which involves expansion, right? But anyway, there's a couple of layers. There's like 2 or 3 different equations that you put together to then give you your final relationship. That's quite a hard one, to be honest. But there are other examples. Same with anything to do with projectiles. You go from your projectile equations to the projectile equation that's very specific to your situation, right? That would be any IA which is following physical law, plain and simple. If you're doing an IA which is new stuff, something that you're not that sure about, what you have to do is the greatest possible effort to try and justify a hypothesis qualitatively, right? So for example, oil and expansion, right? The particles are vibrating, they take up more space, therefore the expansion must be proportional to the temperature because the temperature is proportional to the kinetic energy of the particles, right? You don't know if that's true, and it's kind of an equation, but not quite. So it's a logical justification for a hypothesis. And your final hypothesis is the answer to the research question. So your final hypothesis has to answer this in some way. So if you're using an equation, it'd be quite easy because you'll be able to say exactly how the independent variable affects the dependent. And if you're guessing, well, within reason, guessing intelligently, you would say that the independent affects the dependent, possibly in this way, but basically adding some kind of vague notion that you're not quite sure at that stage. Having said that, hypotheses are not obligatory, right? So if you are doing something that's completely out there, brand new, and you're not even sure what's going to happen, that is not a big deal at this stage. You can kind of compensate for the lack of exploration later in your conclusion. Okay, so that's the first part, the fun stuff, which is the research. The second part is your methodology. And this is kind of more specific. What I need you to do for your methodology is to state your variables and think very, very, very carefully about this. Your independent variable, your dependent variable, and how you're going to measure it, in what units you're going to measure it, and state your uncertainty in your measurement. You got that? So you have to say what you're measuring, how you're measuring it, and to what degree of uncertainty. Your control of variables must be very well thought through because you need to mention every single other factor that could possibly affect your results, right? So I'm trying to apply this to the examples I've given you. With something like a hockey stick and a puck, of course, there's a million factors that will affect the range of that hockey puck. Same with a guitar string, okay? So you need to think what factors will affect my experiment. A good example of this is an experiment that I've seen before looking at the effect of color on temperature of water, basically cooling something down as in different color containers, right? So what you've got there is color, but you've also got other ways of losing heat. The fact that heat can be lost through the bottom of the container, heat can be lost above the container if there's no lid. So you need to think about every single factor that would affect it. You would need to, if you were comparing different colors, make sure that your colors are put on with the same quality paint, the same thickness of paint, the same type of paint material, right? So there you've got an example where you can't, you've got to change one thing, you've got to change your independent variable, but you need to make sure that every other variable that could possibly make a difference is mentioned, right? So really think this through. In the heating oil experiment, if you're looking at the temperature of the oil, you need to make sure that the temperature is the same everywhere in the oil, right? So that would be one variable that would make a difference. You need to make sure that you keep the same amount of oil each time you change the temperature, that there hasn't been any oil loss. So there you would have amount of oil as a variable that you would have to control. right? So for your experiment, make a list of all the other variables that will make a difference, even if they seem absurd. Once you've made a list of all the things that you're going to keep constant, you need to then say how you're going to keep them constant. In what way? So I will changing the amount of oil, but every time I do the experiment, I make sure I measure the oil amount again. So be specific for each one of the variables that you've mentioned. Make sure that you've stated how you're going to keep them constant. And then safety considerations. Always make a statement about any safety issues. So I think for heating up oil, it goes without saying. Very rarely you might have an experiment that's 100% safe, but look for something and demonstrate that you've been very careful in looking at safety. I try and address all of these issues in my checklist, which I will attach to the classroom assignment. That your title contains a research question, that your research question is stated in the introduction, that you identify your topic and describe it, that you have specific and relevant physical laws related to the research question, that there is an equation associated with the research question, that your associated equation is clearly defined and relevant, etc., etc. I will attach this checklist, but basically all of these have to be included if you want to get a 6